Hi, everyone. In this video, we're going to talk about percentiles. So we're going to need percentiles in order to talk about our third and final measure of centrality, which is called the median. So what's the idea of a percentile? So in a sorted data list, we might ask where a particular data point falls within that data set. Maybe within that data list. And so maybe the data point in question is the third data point. Maybe it's the 10th. Maybe it's the 50th. But we don't, maybe it's the 50th. And so this is sort of telling us the absolute position. So this tells us the absolute position. It is the third smallest, third biggest, whatever. But this isn't helpful if we don't know how many data points there are. This isn't super helpful. For example, if it's the 10th data point in that data list, well, is that 10th out of 10? Is that 10th out of 20? Is it 10th out of 10,000? Right? If we're trying to determine, okay, this is a big data point, this is a small data point, whatever. Well, if it's 10 out of 10, then it's going to be pretty big. If it's 10 out of 1,000, then it's going to be pretty small. And so what we can do is we can ask about its relative position. So instead, we can ask about its relative position. So for example, instead of saying it's in 10th place, we can say this data point is larger than 10% of the data point, of the other data points. Or this data point is larger than 50% of the data points. And so statements like these, we don't have to specifically know, okay, exactly where it lies. It's in 10th place out of 247. This gives us a relative picture. It says, okay, it's bigger than a little over half of the data points. It's bigger than all of the data points. It's not bigger than any of the data points, etc. And so this leads us to the idea of a percentile. A percentile is not the same as a percentage, although it does, they are related. So the idea of a percentile is the following. A data point should be in the pth percentile if it is larger than approximately, and I'm saying approximately for reasons that we'll see later, p% of the data points. Okay, and as an informal example, my data list looks like this. So 1, 2, 3, 4. The data point 3 is larger than 2 data points, namely 1 and 2. It's bigger than 2 of the data points. It's not bigger than itself, and it's not bigger than 4. It's bigger than 2 of them. There are 4 data points in total. And so 2 is 50% of 4. Verify that if you want. And so 3 should be in the 50th percentile. But that's not going to, 3 should be in the 50th percentile. That's not quite going to be the case for reasons that we'll see in a bit. And so how do you find the pth percentile? Okay, so how do you find the pth percentile? First, you're going to want to find what's called the locator. And so first, compute the locator, denoted L. Compute the locator by computing p% of n, where this capital N is the total number of data points. And so L equals P over 100 times N. And so now we have 2 cases. There's 2 different possibilities. So if L is a whole number, so if L is a whole number, then what you do is find the average of the Lth data point and the L plus first data point. Or in symbols, then your pth percentile is equal to d sub L plus d sub L plus 1 over 2, where d sub L means the data point in position L. So if you count from the first one, second one, third one, you're going to look for the Lth data point. So d sub L is the data point in position L. D sub L plus 1 is the data point in position L plus 1, etc. So that's if this locator, this L, is a whole number. What if L is not a whole number? So if L is not a whole number, then find L plus by rounding L up to the nearest whole number. So we're rounding it up. And now your pth percentile is d sub L plus. So it's whatever data point is in the L plus position. So i.e. the data point in position L plus. Okay, so let's do an example for this. 1, 3, 4, 7, 10, 11, 14, 15, 18, 20. Okay, so suppose this is our data list. What we need to do is we need to find our capital N. We need to compute. So first we need to compute our locator L, and in order to do that, we need to know the number of data points. So let's say compute the 50th percentile and the 85th percentile. Okay, so first we need to know our N. How many data points do we have? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So N equals 10. Now, for our for the 50th percentile, what we're going to do is we're going to compute our L. And sometimes because we're doing more than one, I'll call this L sub 50. So to do this, we need to compute 50% of 10. So maybe you can do this in your head. If you can't, that's 50 over 100 times 10. So that's 0.5 times 10, or 5. Okay, so our L is 5. Now, is L a whole number or not a whole number? Well, L is 5, so it's a whole number. So L is a whole number. L is 5. And so, I'll get rid of that 50 for the notation. Our 50th percentile is the average of the 5th data point, and the 5 plus 1 is 6th data point. Or 50th percentile is d sub 5 plus d sub 6 over 2. Because when you're taking the average of two numbers, the mean of two numbers, you add them together and divide by 2. It's the number right between them, direct in the middle of D5 and D6. So let's find D5. D5 is the 5th data point. 1, 2, 3, 4, 5. So D5 is 10. That's our 10th data point, or our 5th data point. And D6 is the next one. So 1, 2, 3, 4, 5, 6. So that's going to be 11. So D5 plus D6 over 2 is 10 plus 11 over 2, which is 21 over 2, which is 10.5. And so that tells us that our 50th percentile is 10.5. And again, just like the mean, 10.5 is not part of our data set. We do not have a data point that has a value of 10.5. And so what we can do is, I'll just draw a little arrow here just to show that our 10.5 goes right there between the 10 and the 11. Now let's find our 85th percentile. So our L, in this case, 85th percentile, we find 85% of our N, 85% of our number of data points. We have 10 data points, N equals 10, just like before. So this is going to be 85 over 100 times 10. So it's 0.85 times 10, which is 8.5. So now we're in our second case. If L is not a whole number, we're going to find this what's called L plus. We're going to round L up to the nearest whole number. So 8.5, well, the nearest whole number is to 8.5 is either 8 or 9, and we're always rounding up. And so 8.5 becomes 9. So our L plus is 9. And so now our 85th percentile is the 9th data point, which can also be called D9. And now let's count. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be 18. So 85th percentile is 18. So I'll draw this here. '85th percentile, and this is 50th percentile. Now, I want to make a couple comments here. Let me copy this. Just a couple of observations. Oops. So a couple of observations. Let's look at this 10.5. It sits right in the middle of 10 and 11. So how many data points are less than 10.5? Well, we've got 1 is less than 10.5, 3 is less than 10.5, 4 is less than 10.5, 7 is less than 10.5, and 10 is less than 10.5. Nothing else in our data set is less than 10.5. So 5 data points are less than 10.5. And so that tells us, and similarly, 2, 3, 4, 5 data points are greater than 10.5. And so 10.5, so 5 is 50% of 10. So that tells us that 10.5 is less than 50% of our data points. And greater than 50% of our data points. So it's smack dab in the middle, and this is exactly what we were looking for. We were saying a percentile, something's in the pth percentile, if it's greater than p% of our data. So that's great. What about 18? How many data points are less than 18? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. I didn't count 10.5 because that's not actually one of our data points. It's our 50th percentile, but it's not one of our data points. So that there's 8 data points less than 18. But 8 is 80% of 10, but 18 is in the 85th percentile. So being in the 85th percentile, that means that it should be bigger than exactly 85% of our data values, but it's only bigger than 80% of our data values. Okay, and so this is where it's tricky. Sometimes when you don't have the right number of data values, there's no way to get the exact 85th percentile. And so you have to sort of be a little flexible with that. And so it's also correct to say, so it's also correct by some definitions to say that 8 is in the 80th percentile, or that 18 is in the 80th percentile. So there's 2 different definitions of percentiles, and this is something you should be careful about. Okay, but this is not the version we are using. And I'll say a little bit more about the other version of percentile in a different video, but there is some subtlety here and it can get a little confusing. But as long as we're saying what is the data point in this percentile, if you follow this method, you'll always be good. Okay, we'll look at some more examples in a future video, but that's all for this video.